Here is an explanation for the answer to final exam question number 73 in Trigonometry Demystified, second edition. Please refer to pages 382 and 383. The question asks us that phase quadrature exists in an electronic device if and only if that device contains what? And then it lists 5 different characteristics. Phase quadrature means that the current and the voltage in a device are 90 degrees out of phase. In this graph, we have 2 sine waves, and they are 90 degrees out of phase, and we can tell that because the peak of one wave, say the green one, and the peak of the other wave, say the red one, the positive peaks are 90 degrees apart, and so are all of the other corresponding points on the waves. You'll notice that they are 90 degrees or 1/4 of a cycle apart. That is what is meant by phase quadrature. Now we might consider the green wave here to represent the voltage and the red wave to represent the current. In that case, the current lags the voltage by 90 degrees. If we consider time, get rid of this arrow, if we consider time to go in that direction, the red wave current occurs 90 degrees later in time than the green one, voltage. So in that case, we'd say that the current lags the voltage by 90 degrees. On the other hand, if we let the red wave represent voltage and the green wave represent current, then the current wave occurs 90 degrees earlier than the voltage wave, and we would say that the current leads the voltage by 90 degrees. When the current leads the voltage by 90 degrees, we have a pure capacitive reactance. A pure capacitive reactance. That is in the case where the current, which we can represent as I, leads the voltage, which we might represent as E, by 90 degrees. That's a pure capacitive reactance. In the opposite situation, if we let the green wave represent voltage, okay, if we let the green wave represent voltage, E, I don't know why they use E and I for voltage and current respectively, but they do, so we'll stick with it. If the current lags the voltage by 90 degrees, then we have what is called a pure inductive reactance. This might sound more like a course in electricity than a course in trigonometry. However, these applications in electricity are a common use of trigonometry. Well, after all of this discussion, we go back to the question. In an electronic device, we should expect the AC current and voltage to exist in phase quadrature if and only if that device contains either a pure capacitive reactance or a pure inductive reactance. So, the correct answer, B.